3, 2, 1. Hello everyone, January the 20th. Alright, let's do this. I have a full training session today to go. Grid game. Question number 2017. You are given a zero-indexed 2D array grid with size 2 times n, so 2 rows, n columns, where grid row column represents the number of points at position. Hold a second, I need some water. And I'll grab my water from a bowl. All right, where are we? So grid RC represents the number of points at position RC on the matrix. 2 robots are playing a game on this matrix. Both robots initially start at 0, 0 and want to reach 1 n minus 1. So that's just the bottom right corner. Each robot may only move to the right or down. Okay, so right or down. That makes things a little bit simpler. At the start of the game, the first robot moves from 0, 0 to... The first robot moves from top left to bottom right, collecting all the points from the cells on its path. For all cells traversed on the path, we'll set it to 0. Then the second robot moves from the top left to bottom right, collecting the points on its path. Note that their paths may intersect with one another. The first robot wants to minimize the number of points collected by the second robot. In contrast, the second robot wants to maximize the number of points it collects. If both robots play optimally, return the number of points collected by the second robot. So, okay. So basically, the first robot wants to play optimally. That means that means exactly the same, that each robot wants to collect as much points as possible. And if the first robot take a lot of points, then the second robot doesn't have all those points to take. So yeah, that's pretty much, right? So you want to maximize your points for the first robot. And then you run the exact same scheme for the second robot, and you also want it to be the maximum. But at each position, you can only go right or go down. So it feels like if I run 2 rounds of Dijkstra, I can solve this. So, but instead of getting the minimum, right, Dijkstra usually you find the minimum cost, but here you want to maximize it. So use a max heap, and then that shall work. Actually, I'm not sure. Let me see, if you're in this, yeah, how can you go Dijkstra to pick this 4? Well, I guess you can, because you will just keep going. Oh, yes, because if you want to find the minimum, you always break out from the Dijkstra when you first reach the target. But in this case, you don't, because you want to find the maximum. So Dijkstra definitely will lead you, even with a maximum heap, it will lead you here and then go down. But then there will still be things, like this one will still be in the heap. So this one will pop up, and then it will go here, it will go here, and then eventually the 4 will come. So Dijkstra can work, but I feel like if we do Dijkstra, then we are not taking advantage of the 2 rows and n column thing, and then they're only right and down. So like Dijkstra, you can do this with any, there's no restrictions on the size of the grid and no restriction on the way you move. But now with this restriction, I think there should be a simpler way, right? So essentially, the moment you go down, that your fate is doomed, right? Because you can only go down or go right. So you need to choose the best moment to go down. So what we can do, at least for the first, is we can do a prefix sum, okay, on all of these points. So if we do prefix sum on the points, and then we do a suffix sum on the points on the second row, and then the goal is to find a point where we cross, then the sum of the top and the bottom is the maximum. And that we can do just by going through everybody, right? We go through everybody and then we can find a point where we have the maximum. Okay, so once that is done, right? Once that is done, and then we'll have like this pattern, right? We'll have a pattern where everybody will be 0. So we only have the rest. Then for B, it's either taking everything on the top or taking everything on the bottom. So that can be solved as well using just what we know already. Yep. Okay, I think I know how to solve this. Let's try it. Let's try this. So what we're gonna build, I think I'm gonna do it in place. Ooh, I don't really think you can do it in place though. I think you have to restart it because it's a long thing. So we can say top row, which we're gonna give, let's do int n is grid 0 dot size. All right, grid has to be, yes, grid has to be 2, right? So here I can assign it to n, and then we'll do same thing for the bottom row. All right, so now we have top and bottom, and then we need to do a prefix sum on top. Okay, so to do prefix sum on top, what we need is, first of all, we say top 0 shall equal to grid 0 0. Of course, I think we have to long this thing. Oh, long this thing, just in case. And then for int I, 1i smaller than ni plus plus, we say top I shall equal to long, that's actually not right, equal to top I minus 1 plus long man, grid 0i. Okay, so that's the top. And then suffix sum on bottom. So we say bottom n minus 1. Right, we go from right to left. Shall equal to long grid 1 n minus 1. And then we say for int I equal to n minus 2, I large equal to 0, I minus bottom I shall equal to bottom I plus 1 plus long grid 1 I. Alright, so now we have the suffix and the bottom. So next thing we need to know is at which point we shall swap. Basically, we just go through one by one, we just add this top and bottom, and then we want to find the maximum. So int no long rob1 max, so we set to 0, and then we say int position. All right, so I don't even know what position it is. Then we say for int I equal to 0, I smaller than ni plus plus, if top I plus bottom I is larger than rob1 max, then rob1 max equal to top I plus bottom I, and then we update the position to I. So we go through this, we'll find the maximum of the top plus the bottom. So that's robot 1. So now the robot 2, what we need to return is the maximum of the remaining and the maximum of the remaining. So I can just say return std maximum. So now we need to find the max on, hold on, let me add one more comment here. Find the position such that robot 1 has the max points. Okay, so now here is robot 2 will take the max of the remaining top or bottom, right? So for the top, right, for the top, so it's going to be top n minus 1 minus top position, because positions are taken, right? That, and then bottom 0 minus bottom position plus 1. Now this is a little bit tricky, because if the first one go all the way to the end, right? If the first one go all the way to the end, so position is n minus 1, then I cannot do that, right? Position n minus 1, and then I go down, right? I go down like this. So I need to say this, that's actually just position, right? So at the top, we need, this is the position, so it would be the n minus position, and the bottom will be the same, because this minus the position, so we have the remaining. So that should be the answer. Okay, I think this is the right solution, so I can write this now. Technically, right, this problem can be generalized, right, with NAM by N grid, and each step, right, can take all 4 directions. If that is the case, we can solve it using Dijkstra. However, in the current problem, right, we have 2 restrictions, right? One is the number of rows, and the other is the 2 directions that we are allowed to move. This means for each robot, it only has 1 chance to decide where to switch from the top to the bottom row. Thus, for robot 1, all we need to do is to locate the position such that the switch would produce the maximum points. We can create a prefix sum and suffix sum. Prefix sum for the top, and a suffix sum for the bottom, to easily find such position. For robot 2, its only choice is to either use the remaining points on the top or bottom. Thus, our answer should be the max, the larger of the two sets of remaining points. I'll call it ON. And let's try this out. I run it on the test cases. Looks to be good. Submit it. And we got wrong. Oh, how confident you are. I was very, very confident. And I am definitely not happy that this one does not go as planned. Huh. Alright. What the hell? Seriously, what the hell? Alright, it's alright. Let's use this test case. And we are going to investigate what actually go wrong. Especially, I am so confident in this one. This is really not a good look. But it's okay. Things like this happen, you know? It happens. Oh, I did not copy it well. Did I not copy it? Alright, so a grid, and then this is a grid game. Alright, where do you want to put? Let's put breakpoint here. Let's build this. Today is, no, I think it's 21. Okay, so what do we have? Let's move these. We really don't need this. This is the only thing we want. Get this out. Top, bottom. That looks solid, right? Looks solid. And where do we stand? All right. Okay, so top I, so it'll be 0 plus 99, right? So 20 plus, okay. Next is 23 plus 79. No. 43 plus 69, no. 60 plus I is 4. 62 plus 42, no. That's 5. 74 plus, yeah, that's a no. 89 plus, that's a no. 106 plus 20, that's a yes. Okay, so I have 126. 8, 110, that's a yes. And finally, that's a yes. Okay. So after this, position is 9. So basically go to the end. So 0, yeah, to go to the end. So we just need to find the sum of this. Right? The sum of this, which is 99 minus 3. That is very interesting. 99 minus 3 is 96. Expected 63. Ooh, I think I know. So maximizing robot 1 does not guarantee you're minimizing robot 2. Okay, hold on. Let me think about it again one more time. What is the goal? The first robot wants to minimize the number of points collected by the second robot. Okay, so the goal of number one is not, I repeat, it is not to maximize its own score. It's to minimize the second robot's score. Oh, that changes everything. I think that changes everything. So now I shall say a prefix, so it should be a suffix sum on the top and a prefix sum on the bottom, because we want to minimize. Okay, all right, this is very embarrassing. Okay, let's just change it. So this has to be the top, the bottom, right? We want this to be the bottom. So let's call it bot. Okay, this is also bot, and this is grid 1. This should be on the top, so this should be top, this should be top and the top, and this should be 1. This should be 1 and minus 1. This should be 0 and 0. And this is also should be 0. Find a position such that robot 2 has the minimum points. So this should be robot 2. That's just the result, right? Int max. We don't even need the position, right? All we need to do is we go through everything, right? And then we say I start from 0. So we take everything, but not until 0, because I cannot take 0. Right, so I start from 0, and then we do I plus 1. Right, that's a prefix sum. Right, I plus 1. And then for the bottom, should be this one minus 1. So that's cool. That's cool. That's cool. So we can say top points shall equal to int tp shall equal to I smaller than n. If that's it, then we say top I plus 1, otherwise 0. Bottom point should be I is larger than 0. If that's it, then we say bottom I minus 1, because the bottom is a prefix sum. Oh my god. Bottom is a prefix sum, right? Bottom is a prefix sum, so it'll be that. Otherwise, it'll be 0. And your result shall be std minimum of TP and BP. Now, I don't have to do it this way, but let's just stay like this, and we'll return result. Actually, not sure. Int max shouldn't be long max, or do we have a long max? I don't think we have a long max. Just long max. Thus, for robot 1, all you need to do is locate the position such that the switch will produce the minimum, right? Minimum points for robot 2. We can create a prefix sum for the bottom, right? For the bottom, and a suffix sum for the top to find the min points for robot 2. All right, so we are completely changing how we are doing it. Oh boy. let's try this. Well, I thought it was yeah, the 2 is not the same. Oh, we have an error. What happened? Something is out of range. Suffix sum, that is not right, right? Prefix sum on bottom should start with 0. This should suffix sum is n minus 1. Right, prefix sum on the bottom. Yes, suffix sum on the top. Yes. Well, why would this causing issue? It could be this, but I'm not super duper sure. I mean, technically, it should be also all 3 of them, actually. Oh, one thing. This should be long. Not sure if we can do all 3 together. Yeah, it's probably we can't. So I probably need to add another layer on top of it. Ah, that's where the problem is. All right, that is terrible. Oh, so we shall get this as a long max, right? We're trying to find a max value. Oh, we're trying to find a minimum value. That is still not right. Oof. Oh, it's rough. Oh, this is the max. This is the hold on. What are we trying to do? We're trying to find, so the top points. No. The top points or the bottom points, right? So you either get a top or you get a bottom. And for if you choose that, then it's, this is 0. So here is player B, right? So find such that robot 2 has the minimum points even if it uses the best strategy. And it uses the best strategy by using max here. That shall be right. Oh my god, this is not right. Yeah, so the STD max is the robot 2's strategy, because it will try to find the best it can do. The STD min is the robot 1 strategy, right? It's the main, because at each position that robot 1 decides, robot 2 always can pick the bigger one, but the robot 1 is trying to find the minimum. So it's a min max. That shall work. That one shall work. All right. So yeah, it's not really that hard, but I think I just got a little bit confused about how the whole thing works. All right, this one is done. You can go find the tutorial, prefix and suffix sum. That looks exactly how we do. And lordy, that is a simple. Oh. Accumulate. Darn. Accumulate. Huh. Very smart. Because bottom is a prefix sum, so now that's the second row can just go through this. Very, very smart. Zero long. You can use accumulate. Now I see. You can use accumulate. Yeah, so basically this one you get a prefix sum on the top, but then each step you can remove, right? You can remove and you get the bottom sum, min, max, and the second row. Yeah, this is exactly the solution. Oh boy. Now we did not use the optimal. You know what? Screw this. Let's do the optimal. Let's do the optimal. Because we need to practice at least the feeling of using. So solution 1 uses the correct strategy, but its implementation is lacking. We can leverage accumulate, right? So accumulate, wait, what does accumulate give you? It's a value, right? We can leverage accumulate to quickly find the total sum of row of top. Then as we traverse through the columns, we remove the top value to get the suffix sum. For the bottom, we just accumulate the prefix sum as we go along. In other words, the optimal solution should have O1 extra space. That is absolutely true. So long top sum std accumulate. I never used this one before. Can I say grid 0 dot begin, grid 0 dot end? What's the third one? Man, I don't even know how to get the. Is it hover over? It didn't show me anything. But I know it's this. I think this is just a starting, right? This is starting value, but how do I this is the definition. I don't think you want to go to definition. So let's go back. I remember you just do this and then you can see it's honestly, I forgot how it's supposed to do. Anyway, this is the top, and then we will have bottom sum start with 0. Then we have rest starts with long. Apparently there is long max. Then I smaller than grid 0 dot size I plus plus Okay, then we just update. Right, top sum minus equal to grid 0i. And then we say res shall equal to std minimum of res std maximum of top sum and bottom sum. Right, the same. The best strategy for the second one, and then the best strategy for the first one. Once we're done, we say bottom sum plus equal to grid 1 I. Okay, and then we'll return res at the end. Use of undeclared long max. Huh. I think it doesn't allow me to use long max, but I guess it's fine. Your energy bill is ready for review. All right, we'll take a look at my energy bill. Guess it's not that bad. All right, anyway, I'll submit it, and yes, this is correct. Good. Let's see if the memory, yeah, you see the memory, right? It's a decreasing memory usage. Good. All right, we're done with this, and do we want to move on to the next one? No, I do not. We have a full training session ahead of us. I'll just call it. Okay, then that will be it. I will see you guys tomorrow. Adios.